Hey, how's it going? Just before we get started, just a bit of a note. This podcast was actually recorded a few weeks back when the price of lithium was still continuing to increase. Since then, it has started to trend downwards, but the availability of lithium hydroxide still remains challenged despite the price decreases, and all the technical information that's contained within this podcast still remains relevant, as does the need to diversify away from lithium based thickeners. Hope you enjoy it.
G'day everyone, welcome to Lubrication Expert. I've got a very exciting episode today. Today we're speaking with Dennis Eijdenberg from the Axel Christian company. Now, if you are in the grease world, you know Axel Christiernsson, right? Basically one of, if not the largest private label grease manufacturer. But if you come from outside of the grease world, you may have never actually heard that name before. But these guys are very knowledgeable when it comes to grease applications, grease technology, and that's why I wanted them to come on this podcast to discuss. And there's no one better than Dennis, the man himself. So Dennis, thank you so much for coming on. I'm really excited to hear a little bit about lithium complex. What's the future of grease look like? Because there's a lot of uncertainty in the market now, and hopefully you can provide some clarity to us all.
Definitely going to be an interesting talk. So thanks for having me. And indeed, we're one of the larger companies no one ever heard of unless you know us. When you are in the grease industry, we're sort of the odd one out. We are a producer of lubricating greases only, rather than oil-based lubricants. We only produce lubricating greases. So that's we're in a niche market and have some niche knowledge there as well. So more than happy to share that today.
Awesome. So I thought maybe the way that we could start is, I think everyone is familiar with the fact that by volume, lithium or lithium complex greases, that sort of kind of multi-purpose grease that everyone sees throughout the industry. So I thought it would help if we wind the clock a little bit backwards to go from the start and say, why is it that lithium greases are so popular? Why have they come to dominate the market? Whether it's for technical reasons, commercial reasons, why is it that lithium really has the lion's share of grease volume?
Yeah, fair question and an interesting topic to look at. If you look at it from a historical point of view, there's roughly pre-World War II and after the Second World War period. If you look at lubricating greases pre-Second World War, you would have your sodium greases or your regular calcium greases, some aluminium, and any of those clay or benton greases, and they all had some positives. If you look at sodium grease, for example, they have perfect water resistance, but they're very poor in the presence of water, as they're basically salt. If you look at it the other way around, the old-fashioned calcium greases were highly water resistant, but as water is part of their chemical structure, you're sort of limited to upper temperatures of 60, 65 degrees before your soap starts to disintegrate. So in that period of time, you had to make some choices which features were most important in the application you were trying to service. So then in 1943, along came Clarence E. Earl, who found out a way to do a saponification with lithium salts. So basically the first lithium containing greases. Simple soap lithiums sort of gave the solution to actually create a multi-purpose or universal product, as it solved the issue of being quite bad at some features as well. So water resistance, mechanical stability, resistance to shear, pumpability, all of those, it's working quite decently. It doesn't excel at anything, but most importantly, it's not bad at anything as well. So that there was basically the birth of true multi-purpose greases that were fit for a number of applications without having to choose whichever feature was most important for you. And then building on your lithium grease, and just a side step, in order to make a lubricating grease, you would need thickener, usually a soap or a non-soap thickener. Soap thickeners would be a metal hydroxide and a fatty acid reacting. So lithium hydroxide in this case. You would need a base oil and some additives as sort of a cherry on top to enhance performance wherever you want to. Looking at your simple soap lithiums, then they were evolving after the Second World War with different base oil types, different additivation types to build on there. And then there's a couple of options you can do in terms of enhancing performance. First step would be lithium calcium greases, for example. If you do a double saponification process where you combine lithium hydroxide, calcium hydroxide together in your saponification process, you get a product with basically a multi-purpose product for higher demanding applications in terms of load carrying capacity, shock load resistance, and water resistance as well. So you enhance those features with lithium calcium greases. So that's one part in the market where you see your lithium universal multi-purpose EP2 products. Then your lithium calciums for more demanding applications, mainly outdoor applications as well, where water or dirt are usually problematic. And the other way around, lithium complex greases, where we do a first saponification step with a first fatty acid to create a lithium soap, and then the second step with a debasic, or that's laic acid, any of those, to do a second saponification step and create a lithium complex with some benefits in terms of thermal resistance that goes up. So you're able to work at higher working temperatures or prolonged higher temperatures, and your mechanical stability, so your resistance to shear, improves quite well as well. So lithium complexes and lithium calcium are not on the same page in terms of performance there. And then you would have a lot of other versions where lithium would be part of it in some spun-offs or hybrid version. But those are the main three ones you see in the market. If you look at it in Europe, lithium tends to be the dominant thicker for your multi-purpose universal greases. If you look at US, for example, lithium complex seems to be more the weapon of choice there, and so lithiums are not too popular. So from a historic point of view, basically lithium provided some building blocks to basically capture a lot of quite well performance details and some other saponification steps to tweak those further along.
That's really interesting. So what you've described is lithium as kind of being a jack of all trades, but master of none. And that's what makes it a multi-purpose grease, right? Like it's pretty good. It doesn't have any major weaknesses, so we can use it quite widely. And I guess if I can give the analogy in the lubricants world, where we are always looking to rationalize products, right, and have the fewest products on site, lithium gives you that capacity to build that rationalization in from the start. So we just have a single thickener that we're using across a really wide number of applications.
Just add on a bit there, if I may.
Yeah.
It's basically three things if you want to oversimplify it to understand how lithium became there. It's basically three A's. Lithium was available, which is of course of importance, and perhaps a nice bridge to the current situation, because as a spoiler alert, it's not that well available anymore. But it was available. It was affordable as well. Lithium wasn't too expensive altogether to be used in a saponification process, and it was all round. And that all round is what you're featuring as well, with the availability and the affordability of this lithium hydroxide were key into getting where we are today as lithium being the dominant thickener type used.
That's really interesting. So I think most of the listeners of this podcast are, technical professionals from the lubricants world, and they probably do understand the difference between a simple and a complex lithium, right? But just for the few listeners out there who might be a little bit confused about the terminology that they're throwing out there. So the way that I always describe it is that a simple soap is kind of like, you've got a polar head and a long fatty acid tail. And then the complexing process is almost like those acids, like the long sections on a ladder. And then when you complex, you're taking another acid, an azelaic acid or something like that, and you're bridging the two of them together. So that's almost like putting rungs on the ladder, and that kind of gives them more, let's say, mechanical stability. Is that a fair characterization? And where does that analogy maybe break down a bit?
It is a fair analogy. What I occasionally do as well is make an analogy with a sponge. If you were washing your car for your dad on a Sunday morning to have a little earring on the side, for example, if you have a very open structured sponge and you take it out of your bucket, then water flows out quite easily. And if you pull on that sponge, you easily tear it to shreds. That's basically the equivalent of a lithium simple or a simple saponification, because in the end, with these fatty acids and metal hydroxides, we are forming a similar saponification process, a soap or a sponge in that matter. So if you would have a very dense sponge, a small air pockets in there, and you pick it out of your bucket as well, water hardly flows out. So you need to squeeze in order to get your fluids out of there. And if you want to pull it, it's very hard to tear it apart. So that's basically a complex compared to a simple soap. The more intertwined those links are, if on a ladder or in a sponge for that matter, the more resistant they are to shear, for example. Shear basically is the constant milling of your product, for example, in wheel bearings of trucks or on-road transport. There, your constant milling is basically the equivalent of constantly pulling on your sponge altogether. So the more links there are, the better it is for mechanical stability. It enhances your thermal stability as well. The more links there are, the higher your dropping point is. So the harder it is to, in the end, break those bonds by means of temperature. That's basically what your dropping point does. And if you look at it from a practical point of view, the more soap there is, so the more of those particles there are that are intertwined, the harder it is to get your oil out. And in the end, the oil is something that is highly contributing to creating a lubricating film in the end. So if you have a very slow moving application, probably not all complexes are suited to be working in there. So you either need a higher speed in some cases or a higher load in order to still get your oil film and your lubricating film created.
Yeah,
But
that's
all in all, it shows the intertwining of the more intertwined it is, the more complex it is indeed.
yeah, that's really good insight. And I think that analogy is going to help a lot of people sort of pull that understanding together. So now that we've got the kind of the basics of the technical details down, talking commercially, would you be able to give us a rough rundown of kind of market size in terms of like what's the share of all the different types of greases? So broadly speaking, we've got the simple lithium greases, the lithium complex greases, and then you've got, like you mentioned, the clays, polyureas and things like that. How dominant is lithium when it comes to most of the industry?
Well, if you look at Axel from a product production point of view, for example, where I would have most insight into anyway, I think over 3/4 or even 80% and up are greases that contain lithium in any way, shape, or form. If you look at industrial products, if you look at the European market, for example, roughly 70% of the greases there contain lithium. And then you would have your other thickener types. Non-lithium containing greases, for example, would be calcium or anhydrous calcium. I think we'll capture a bit on that in a bit later on to explain the differences there as well. Calcium complexes, aluminium complexes for especially food grade applications where we're seeing most of them. Calcium sulfonate complex greases and polyurea greases are sort of the major thickeners we're seeing for non-lithium containing products altogether. But all in all, a substantial part of the market is using greases that contain lithium in any way, shape, or form.
Yeah, that's really interesting. And that explains why the market disruptions have affected so many different industries, right? Because of lithium's dominance, right? And so the obvious question, because I think everyone is feeling it at the moment, end users are seeing it in the price of grease at the moment. They're seeing the price of lithium-based greases in many instances skyrocketing, even relative to other products that they might see from their lubricant suppliers. So the price of everything has been going up. We can blame supply chain shortages and all this kind of stuff related to COVID and shipping issues and production shortages and all the rest of it. But even relative to that, it seems, at least with my customers, that lithium greases are increasing even above that kind of standard level.
Agree.
So with all the discussion about it, it's helpful to understand why is it that the cost of lithium has gone up so much? And, is that driving a search for alternatives to lithium or substitutes for lithium? Do we see this being an ongoing trend that we need to, as an industry, address? Or is it something that is kind of transitional and we'll get onto the other side and lithium will become cheap again and everything will continue as normal?
A lot of questions. Let's start off with the one I thought you were starting off with. Is it correct that lithium is the main contributor to increasing prices? And it is. The price of lithium starting 2022, beginning of 2023, prices are going up tenfold. So it's going from roughly $8 to $10 a kilogram of lithium to now $85 for that same kilogram of lithium and up. So it's
Wow. I did not
definitely
realize it was that much.
it is definitely has an impact, and it's sort of limited now. The impact is sort of limited at some point because base oils overall tend to be going down. If you look at a production point of view, Group 1 base oils are still your mainly used type of base oils, mainly because the more refined the product gets, the lower the viscosity gets. If you look at the trend that you see in automotive industry, for example, to continuously decrease your viscosity needed. Look at lubricating greases. We're not on that, following that same path there. Higher viscosities, higher loads, water resistant qualities, all of those. Roughly 200 centistokes is not too much if you look at lubricating greases anyway. If you look at at an engine oil, 200 would be ridiculous. So it starts sort of to get interesting at 200 centistokes if you look at 40 degrees. If you look at lubricating greases. So the cost price of lithium has gone up tremendously. And the main reason is the amount of lithium that's currently being needed for energy storage. And it's not necessarily you store energy in lithium, but lithium is the main component that's being used in high performance batteries currently. So two pillars where we are basically seeing a huge battery demand increase. First of all, EVs, PHEVs, any battery operated vehicle that's currently in the market would have batteries containing lithium. Lithium would have quite high electrode potential, a high energy storage capacity, even combined with higher temperatures. So it's right as where lubricating greases are as well. If you look at your batteries, lithium there solves a lot of the issues you would have with other solutions as well. It's your jack of all trades, as you said it, in terms of batteries as well. So your dominance within the EV markets for batteries containing lithium, that will only be growing. There's a lot of initiatives globally to phase out internal combustion engines in cars and trucks and buses and everything that moves or has motion and at least two wheels or four. So they're going from a market there where there's a huge potential of batteries, energy storage in grid storage or nuclear power energy storage as well, or wind energy. You want to store energy somewhere. So lithium is needed as well to create those batteries. 2015, looked at a study of Klein at some point. In 2015, roughly 30% of the lithium that was available in the market, roughly 30% was being used globally in lithium containing greases, so as a saponification medium for lubricating greases. If you look at it nowadays, we're roughly at 10% market share that's still being used in lubricating greases, even though the lubricating grease market is very stable in terms of volumes anyway globally. If you would look at it to 2025 or even 2030, we're under 3% as the predicaments are, because the amount of lithium required in those batteries is such a high vast potential that every lithium mine or grinding operations, they will be producing for batteries and not so much for lubricating grease or healthcare or ceramics or any of those where lithium is used as well. That said, if it appears that there will be roughly enough lithium to go around to be able to produce as many batteries as you can to keep up with the EV trend that we're seeing, the energy grid storage trend that we're seeing as well. However, it's sort of in line with a demand and supply being available. That's both going up. So prices will be balanced and we won't see prices going down, at least from our point of view, anytime soon. And knowing that our, as lubricating in lubricating grease market, our market share, even though volume wise, we're sort of in the same arena anyway, but we are getting to a smaller and smaller part of the pie. So we're not really in a position to demand lower prices, even if they were possible at some point as well. So lithium is at best continuing at the high price level we're seeing today. Most likely we'll see gradual increases overall altogether in the upcoming period as well. And
Yeah.
that,
So I guess the way that you would look at it is as an industry, our relative purchasing power compared to the lithium market goes down, even if supply and demand are matched.
yeah, that's exactly what it is. Yep.
Okay. So that then brings us to, if we do see a period of sustained high prices and lithium occupies a large portion of the grease market, then it would make sense to look at alternatives. And so from your perspective, what do you see as being the main candidates for replacement technologies? And with lithium being that sort of jack of all trades, as we start to introduce substitutes, are they going to have to be more specialized than the multi-purpose lithium greases were? Or are we able to find substitute multi-purpose greases as well? Off the top of my head, and you've already mentioned some of these, you've got sort of the calcium lithium combinations. I think heard you mention anhydrous calcium. We can get into what that is because I think there's a few misunderstandings about what that might be. Calcium sulfonate, polyurea, all the rest of it.
If you summarize it again as to the 3 points, the availability, the affordability, and the all-around qualities. Availability and affordability, well, they went out the window with lithium altogether, lithium hydroxide. So we have an all-around product, and that's not enough to sustain itself as dominant thickener in the market. Let's start off with some drawbacks, and then we'll get to the positives later on. That's at least to keep our audience listening as well, rather than to say, well, that's the conclusion that we don't bother. Now, some challenges we see ahead to phase out lithium altogether in some applications. It's a matter of OEM instructions at some point, or guidelines, where a lot of the OEM's instructions or OEM requirements are demanding lithium-based products. That could either be by describing a certain dropping point, a certain thickener, or certain features that tie in with lithium or lithium complexes. So and you can say a lot about automotive OEMs, for example, but not that they're changing on a daily basis. So it will take, in the end, some time to, in the end, get that part of the market to change as well. Other OEM recommendations as well, where if you have something that is containing lithium prescribed currently, it will take time before they have made their choice on what type of thickener or what type of product they deem worthy of being an alternative, and then to be spilled onto the market, where you want to assess compatibility of those two thickeners as well. Of course, if you would have thickener A, thickener B, and they're not compatible, it doesn't make sense to use them in the same machine altogether. That will create issues where you need to do a full flush of your systems and so on. So there's some challenges where we would still see lithium requirement anyway. And as you mentioned as well, a lot of the experts in the market currently are very aware of how lubricating oils work, what their drawbacks are, what their benefits are, and so on. Gear oils, hydraulics, any of those where you would see a lot of people having a fair bit of knowledge in that field. If you zoom into the niche market that lubricating greases is, the number of people that truly understand those products, that's smaller than looking at lubricating oils. So if we as lubricating specialists not fully understand lubricating greases altogether, how can we expect the market to understand it as well? And if you are a farmer, a maintenance technician at a factory, or already of those people who in the end make their purchasing decisions to use a certain product, how are we going to get the information to the market by means of major oil companies, your distributors, grease specialists, distributors, people like you and me talking about products as well? It will take some time to pour energy onto the market about the available alternatives, the do's and don'ts, and so on. So there will be also a delay effect where people might be a bit reluctant to switch to another thickener, because as I said, we have used them since 1945 on. The other matter is the full scale of the operations. Roughly said, if 3/4 of the market now contains lithium, it's a huge scale up to get any other thickener type to phase out lithium altogether. So we still will be seeing lithium tomorrow and the day after as well. It's not going to be a one day process. It will take quite some time. However, people are more willing to change the moment their purchasing power is involved, influenced as well. So if we are finding alternatives that are working equally well, or at least have some enhanced performance in some cases as well, enhanced performance being a benefit, but if you use a product for a certain application, enhanced performance doesn't necessarily always is a necessity, because the product you have might just do the trick quite well. But you would have some enhanced performance and a lower cost price, and especially the second one, that will drive people to say, well, in that case, I'm willing to try, rather than the other way around saying, well, we've got an alternative and it's more expensive as well. Then the willingness to switch over to something new is a bit lower, of course. Looking at your question of which options do we have, and rather than just shouting out all types of thickeners here, it might be good to zoom in to how do you actually get to the right choices, the right lubricant. And that is basically making a combination of which type of application are you lubricating? Is it a bearing, a plain bearing, rolling bearing, pin bushings, any of those, wire ropes, open gears? So what type of application are you lubricating? And what's the environment it's being used in? So the working environment, is it cold? Is it warm? Is there water present, dirt present? Where lubricating oils are usually being used in an enclosed system. Lubricating greases tend to be used in semi-open or fully open applications. So they are more in contact with the environment they're being used in, and pollutants such as water, debris, chemicals, any of those would have an influence on your thickener choice. And lastly, make a combination in which type of machinery are you using? Is it an excavator? Is it a tractor? Are you looking at the electrical motor bearings, wind turbines, any of those? So with those three IDs, the type of component, the type of machinery, and the type of environment, and the performance qualities required, then you can zoom into which thickener base oil additive combination would work out best. And if we zoom into the thickeners, first off, your standard multi-purpose universal products as they are currently in the market, plain lithium grease, or US some lithium complex, but let's focus on simple soap lithiums to start up with first. You have a general all-round good performance, jack of all trades, as you said. There, anhydrous calcium would be the first option to tick all the boxes that lithium simple soaps do as well, and some more. So you mentioned as well standard calciums and anhydrous calciums, the difference between those two, that's what you were getting to as well, right? Yeah. Original calcium grease, as they were used pre-World War II as well, their water is in the chemical structure of a lubricating grease, meaning if water is part of your chemical structure and water tends to evaporate at some 60, 65 degrees already, your chemical structure will simply disintegrate because of the temperature reached at 60, 65 degrees. So you're fairly limited in upper temperature, but you would have excellent water resistance with those greases. If you would look at anhydrous calcium, which is basically a fancy way of saying water-free calcium, water-free calcium doesn't contain water in its chemical structure anymore. So that's taken out, meaning water is no longer part of the equation, where that is the limiting factor in terms of 60, 65 degree upper temperature use. So we are looking at a thickener that, if it's well formed and the solidification process went well, you're looking at roughly 130 or even 140 on an Fe9, for example. Fe9 to assess upper temperature limits, 130, 140. That's really at the level lithium greases are, or even slightly above. But still, if you look at higher temperature operations, your universal product might not just be where you want to be in terms of prolonged lubrication intervals anyway, but in terms of 130, 140 degrees upper temperature on Fe9 for anhydrous calcium, that ticks one of the major boxes in terms of enhanced temperature performance compared to the old-fashioned calcium greases.
So maybe just to clarify on the anhydrous calcium, So we said that with standard, pre-1940s simple calcium soaps, they included water as part of the process or part of the final product, and therefore they had good water resistance. So does that mean that the converse is true, that when you have anhydrous calcium, which is non-water containing, that the water resistance performance degrades?
No, it's a matter of how the saponification process went and the chemicals behind it. So in the end, the calcium part altogether, same as with lithium calcium grease, for example, having calcium as part of your thickener structure, that will enhance water resistance in a substantial way. And if you look at anhydrous calciums, they're even hydrophobic, meaning it's even hard to mill in water at your grease in running. So 1 or 2% of water, that's sort of it. If you look at calcium sulfonate complexes, for example, they are very good in incorporating water in its grease matrix, so preventing rust and corrosion from embedding it in the soap structure. And here's calcium continuously wants to keep that out anyway. So it's a thickener that's originally developed for marine purposes altogether because of the good adhesive qualities that it had, as well as the a very good resistance to water and the inability to absorb water into a high extent just to keep pushing water out. So that's as far as water resistance goes, calcium and anhydrous calcium are really on top of their game in terms of performance there. And even the lack of water in its chemical structure doesn't influence the end result of being not as water repellent.
Right.
So zooming into a bit more details on those anhydrous calcium greases. So if you look at your simple soap lithiums, you will see thermal performance. That's something we've covered, roughly 120, 130 degrees upper temperature. That's met by anhydrous calcium as well. Good load carrying capacity. Same there with anhydrous calcium. We can additivate the core in a very similar way to lithium to overcome any loads. 3,000-4,000 newtons on a 4-wheel weld load machine should be achievable without any issues. That's where your lithium greases are still used as well. If you're going up, we'll border into those lithium calcium grease, for example, for higher load carrying capacity. So we'll get to that a bit later on. But your anhydrous calcium in terms of load carrying capacity, in terms of water resistance to dirt as well, adhesiveness, it's right there on the money together with lithium soaps. Water resistance is a bit better as well. One of the other benefits is a slightly higher mechanical stability. So it's a thickener that is a bit more shear resistant. And lastly, the adhesion of the product is quite well as well, if you look at it from a thickener point of view. And not necessarily coming from the thickener alone, or looking at a thickener, but the pumpability of the final product. If you use an anhydrous calcium product, the end result is a not very elastic lubricating grease that you have. Meaning, if you have those in the centralized lubrication systems, long pipes, and you press onto your grease, if you make the analogy to a sponge again, if you squeeze it quite hard, what happens? The liquids come out. Same there. If you have a soap that is a simple soap, for example, that is fairly elastic, it's easier to get oil separation going, but that will also create some issues in your centralized lubrication system. In the end, you want your lubrication system to be a matter of transport only and not create oil separation already. That should be done in your application where they're actually lubricating. So anhydrous calcium grease is very pumpable, low temperatures, but in centralized lubrication systems as well. So quite some benefits there. Main advantages, if you look at your cost prices of lithium hydroxide currently in the market, and as we said, well over $80 a kilogram. Calcium is lime, right? Prices of lime are slightly cheaper. So that whatever doesn't have to be put in a grease that's quite costly. You don't have to pay for it in the end as well. So it gives a lot of benefits in terms of being more affordable than a lithium type product is. Lime is fairly available. It's affordable, and it is all round, making it your first selection of products where you want to be with universal or multi-purpose type products. If we then look into lithium calcium greases as a next step, where you want to have enhanced water resistance, so your multi-purpose product for more demanding applications, outdoor applications, water present, dirt present as well, higher loads, higher shock loads. A substantial part of that market could be phased out by your anhydrous calcium grease as well. The water resistant and dirt resistant qualities in some cases added by or increased by adding some polymers as well to further increase adhesiveness, stickiness, and the dirt repellent qualities. Additivation levels, higher basal viscosities. The first part of that lithium calcium market could be phased out by anhydrous calcium grease as well. If you go to your truly high demanding, high load applications, high shock loads, and then you're looking at machinery as big excavators, grinders, heavy off-road machinery, machinery used in dredging purposes, for example. So big, bulky, slow, heavy moving, then anhydrous calcium at some point will not be fit for purpose anymore. And you would border into, for example, calcium sulfonates. Calcium sulfonate complex greases would be a next step where they are extremely they have an extreme mechanical stability. They are quite shear resistant, especially at lower temperatures. It is a multi-complex thickener, so it's a combination of some gel, some fatty acids, some metal hydroxides that form in the end a very complex soap structure. So a lot of intertwining and a lot of steps and cross steps on your ladder. Calcium sulfonates, good upper temperature levels, higher than with your regular anhydrous calciums or lithium calcium products or lithium products, but an extreme load carrying capacity. And it's a functional thickener, meaning a lot of the load carrying comes from the thickener itself rather than from EP additivation. So it's a very heavy duty thickener. That is your next step. So anhydrous calcium and calcium sulfonates is your truly heavy duty step rather than a highly additivated, high viscosity lithium calcium grease. At least one, lithium complexes. We see lithium complexes being used in sort of two major ways in the market. First off, lithium complex, we tend to see them in some off-road applications as well. 400, 600 centistoke base oil, some polymers added, usually some solids such as molybdenum disulfate, for example, to be working quite well in your pit bushings, for example, in excavators, where you would have slow oscillating movements, hard to build up a lubricating film, some solids present to prevent metal to metal contact there. That type of lithium complex use, calcium sulfonates or even anhydrous calcium, but to a higher additivation level, would do the trick to phase that part out already. So that's not a true optimized use of a lithium complex in terms of performance. The true benefits of lithium performance come in the other pillar that we see, and that's higher speeds or higher continuous milling, so higher shear. And that's something where we would see that, for example, in electrical motor bearings, wheel bearings, any of those applications where you would have constant motion, bearings, roller bearings, where the grease is really under stress for a longer period of time. And usually, if you look at wheel bearings, for example, higher temperatures and higher peak temperatures, they're quite close to your brake systems as well, of course, generating a lot of excess heat whenever a vehicle is slowing down. Those peaks are quite well absorbed by lithium complex greases. And that is currently where we see some challenges to phase that part out as well. Lithium complexes have a higher content in lithium hydroxide than a regular simple soap lithium. It's roughly twofold, in some cases even 2.5-fold the amount of lithium used. So the cost price increase has been even more exponential than with your simple soap lithiums. That market, we are seeing some options to phase that out with polyurea greases, for example. And polyurea greases are a design thickener where you would have your isocyanides and amines, and you would create different types of isocyanides and amines to in the end form a polyurea grease. And polyurea grease is sort of a container where there's a lot of different polyurea grease. You have your monoureas, diureas, et cetera, et cetera. So there's no polyurea grease doesn't tell you too much already of the actual thickener there. It's a non-soap, so it's more of a melting process, so to say. But those isocyanates and amines are providing you with the building blocks to create a tailor-made product there. So it's sort of a designer thickener. And if you look at your polyurea greases, we simply said we can divide them into two major segments. One are the non-shear stable ones, where you would see, for example, in agriculture use in the US. The other ones are the shear stable ones. And the shear stable ones in your lithium complex is both used for prolonged upper temperatures that the product is being used in, higher mechanical stability. Their polyurea would be a very interesting thickener to look into for some alternatives. Some of them are there already, but polyurea grease have some drawbacks in terms of practical application. The raw materials by itself are toxic. It's toxic raw materials, so worker safety, meeting rules and regulation compliances when producing those really make it a different type of thickener to work with than your regular product, so to say. It creates a bit more stress on the ones in the end producing polyurea greases. The capacity to make sufficient polyurea grease for the market demand currently is too low globally. There's really quite a cry out for more polyureas and the scale up to do so, and to especially knowing that your production side will have to be quite well fitted to meet those more demanding production rules and regulations and meeting worker safety. Those are limiting a vast rollout of polyurea grease altogether currently. But it is an interesting one to look into as well, as it is one of the prime candidates to phase out those lithium complex. So quite a long answer to sort of, rather than saying here's the alternatives, hoping to give some more input on where those different alternatives could be used along the line as well.
You mind if I just jump in with a question about the polyurea greases? So the way it was explained to me once was that one of the big advantages of a polyurea grease is by nature, and because it's not really a soap style thickener, it means that it doesn't contain any metals. And of course, metals being catalysts for oxidation means that polyurea greases are really suited to high temperature, long life applications. Is that a fair assessment of that technology?
Thermal stability is excellent for polyurea greases. It's thermal stability is really one of the fortes of these polyurea type products altogether. Water resistant qualities are quite okay. Load carrying capacity for polyurea grease is quite poor on the other hand. So you need to substantially additivate in order to accommodate higher loads as well. However, looking at where they're being used in a shear stable way, higher speeds never equal higher loads as well. That doesn't exist. The higher load of the disc, the slower it gets. You never see. In general, you would be stuck in traffic behind the truck. Now that's over exaggerating because they're slow moving. But in general, slow moving, higher loads, higher moving, lower loads. It's not necessarily an issue. A shear dependent, the shear quality is dependent on the Lego blocks you're using there. But shear stability could be really up into the highest parts of the market as well. But yep, thermal stability key for polyurea grease indeed.
Yeah, cool. And that's obviously another point that goes back to your discussion about how polyurea is really an umbrella term for an entire family of different greases, right? Because you do hear polyurea as having a reputation for shear instability, but that obviously only applies to certain types of polyurea greases, whereas you can actually make them in quite shear stable forms that are applicable for long life. Okay. So I think that pretty well covers most of the possible technologies. So I always like to end these interviews off with kind of a look into the future. Yeah. And I think you've given us a bit of a picture of here's the rough technologies that we think could be used as substitutes to lithium greases. How do you personally, you don't have to speak on behalf of Axel Christian or anything here, but if you had a crystal ball and you had to be place money and put bets on where do you see the technology being used, what do you think that the next, let's say, 10 to 20 years looks like? Like our industry is pretty conservative and it's slow to change, right? Like you said, when you try to change 70% of the market, that doesn't happen overnight. So if you had to forecast out 1 or 2 decades, what do you think are going to be the overarching trends that we should look out for?
My crystal ball occasionally is a bit off, so I'll try to do the best as I can. But if you you might wanna involve some other trends that we're seeing in the market. First off, is that we in the last period we have seen a shift from using multi-purpose EP2 products for everything towards more specialized products meeting evolving demands. So that already is something that is in process to step away from a one size fits all, fairly okayish product to a specific product tailored for specific needs and enhanced performance or prolonged lubrication intervals, for example, in that type of field. So so that is something where we already seeing differentiation, and the phasing out of lithium in some applications or segments would tie in quite well there as well. It is capturing on what we were already doing. Lithium being more price sensitive than some of the other thickeners currently in the market will, especially for the lower demanding application, will trigger alternatives sooner than with highly demanding applications. In the end, the more expensive your machinery is and the harder it is to stop something, or the more impact it will have if your production process will come to a halt, either for maintenance or repair works. The more likely it is that the impact of a higher cost price of a certain product will not be that high effect if you look at it at a total cost of ownership point of view. So that part you will see a bit slower to respond probably. And there things as compatibility between the two products. And not only from a thickener point of view, but looking at your full types of products that you're using, there you would see a lot more input on a local scale, on an application type of scale. This is the product we're using now. How does the alternative work? Is it compatible? Do we need to stop everything, et cetera, et cetera? Are there any changes in the workings of your application? So the more specialized it gets, the more specialized the solution will be, and the harder it is to roll it out on a larger scale altogether. Then it is not necessarily a buzzword anymore, but sustainability, occasionally you hear that coming along as well, as being of somewhat importance. And that sustainability and lithium don't necessarily go quite well hand in hand. Lithium hydroxide is not the most environmentally friendly or sustainable metal hydroxide to come by. It's either by means of mining or brining. So a lot of carbon, a lot of water pollution that you would see in the end. Not really sustainable, as well as some classifications might be ongoing as well to look deeper into lithium hydroxides from a health point of view to see if that's still the product you want to be working with. So looking at sustainable solutions, for example, anhydrous calcium is an extremely sustainable thickener. So that will help to where we see a part of the market shifting towards more sustainable lubricants, or EALs, even environmentally acceptable lubricants, where you could measure them by either meeting a criteria in US as VGP 2013, or VIDA, you have to call it now, the Vessel Incidental Discharge Act, where you have some set of rules and regulations that you need to meet with your lubricating grease in order to pass that. Sustainable initiatives as the EU Eco label, the Blue Angel, or the Swedish standard 15570 in Sweden. Any of those that tend to make sustainability measurable, they have some strict rules and regulations in place as well, and with which type of thickeners you can work with, or base oils you can work with. And a part of that lithium containing market will slowly be phasing out to more sustainable alternatives, and there lithium doesn't necessarily have a good place at the table. In some cases you can use lithium, it's exempted, but it's not your ideal solution there. So sustainability, a more specialized market anyway. So shift towards more specialized products. They are already setting up some shifts in the market already. The affordability of alternatives, as we predicted, for lubricating greases, lithium as a raw material, it will never be cheap again. So for your cheaper end of the products, lithium will most likely be the first to be looked into alternatives, but that's the biggest part of the market as well. So it's not going to be overnight, but we'll see a shift there where people are gradually starting to pull away from lithium containing greases.
Yeah, that's fascinating. So I think, it's very interesting times for everyone, right? In the standard lubricating oil market, we've seen a lot of shifts over the last couple of years, and we're starting to see that spill over into the grease market. I think we're likely to have a few disruptions ongoing for the next couple of years. And so it's really nice to hear from an expert who's in the thick of it and get your opinion as well as your technical understanding of the market as it stands now. So Dennis, thank you so much for sharing your insight and your knowledge as well. We really, really appreciate it because I know this is a topic of interest for a lot of people. And if you're okay with it, we'd love to have you back to talk some more technical details on some specific greases as well. So thanks so much for your time, and we'll talk soon.
Thanks. I appreciate it. What an interesting talk, and more than happy to join again. So have a good one, and see you soon.